sequence request, you can see here I'm going to tell it just to go to localhost on port 80. So it's just going to go to itself on port 80, which doesn't necessarily make sense, but we do know at least that that port is there and it's open. So I can make these requests all day long, and you'll see here that I'm getting an accepted that comes back within a second or two. So now let's change this to some other random IP, like 1.2.3.4, and hit submit. You'll see I immediately get a response back, but if I issue a second follow-up request, I'm not getting my response back. And the reason for that is that it's waiting for that initial request to time out. And once it does time out, it'll then return a response to me. So I thought this would be interesting to sort of play around with. And in sort of doing some research and kind of playing around with it, I developed sort of a crude console application that I called WS Dual Scanner. And really what this does is it converts any web service that's using this binding into a remote port scanner. And the cool thing is that because depending on where that web server is, you can actually start scanning other machines in the same DMZ or on the intranet, depending on where this thing is, through this callback request mechanism. And it's a little slow, but it is effective. And the way it works is it basically issues the first request, doesn't really care what the response is to that because it's going to always come back immediately. But then on the second request, it's then going to wait and measure the response time to figure out whether the first connection timed out or not. And then it's just going to keep on doing that and probing different ports. So to do a proof of concept, what I did was I actually created a web service. It's a standard calculator web service from MSDN, and actually deployed it to a VM in the Azure cloud. So the way Azure works, which is Microsoft's cloud platform, is you can publish, you buy a subscription, you publish web services in VMs that get deployed into the cloud. And the way their cloud works is it's actually sitting on a 10-dot network with all the other VMs. And it's behind a firewall that they then translate your host name. So every time you deploy an app, you create a host name. So if it's myapp.cloudapp.net, and cloudapp.net is the standard domain that Azure uses, that's actually going to be translated inbound to one of the VMs on the 10-dot. So what we're going to do here is just the proof of concept. I'm going to pull up the web service that I've got here, and we're just going to quickly try and scan the other VMs. I actually have an internet connection here from my Verizon card. So you'll see this is the actual URL to the Azure web service, which is sitting on the Microsoft cloud right now. You'll also notice here, which is kind of what we talked about before, I'm getting the internal host name of that VM. So if I tried to pull the metadata and tried to resolve it with the WSDL that way, all of my utilities are going to break. So the reason I'm pointing that out is just keep in mind you'll need to use something like burp. If you're actually trying to pull the WSDL and do testing, you're going to need to use a tool that does a search and replace on these host names. Otherwise, you're not going to be able to talk to it. But for now, the way this little port scanning thing works is it's pretty crude. It basically just takes in, let me just pull it up here. So it basically just has two options. You can either scan a range of ports on a specific machine, or you can scan a specific port across a range of IPs. And if you look back at that helper page here from the Azure web service, you can see it's actually running internally on port 20,000, which you'll notice here. And that, again, for some reason, they run all the internal VMs run their web services on port 20,000. That just gets mapped to port 80 when it does the inbound NAT. So what we're going to do here is we're going to go ahead and launch this against, I'm going to point it towards my web service, and I'm going to tell it to scan, and it's kind of slow, so I'm just going to do about 10 IPs right now. We're going to tell it to actually scan 10.115.213. I know that's the network that my VM sits on. We're going to have it scan .30 to .40 on port 20,000 and see what other machines have that port open. So the way it works is it just actually measures that response time for that queued response that I was talking about before. So you can see here it's already measured the response time as around 7 seconds for the boxes that are not listening on that port. Either it's closed or it's probably just timing out. And then the ones that do have that port open, it's getting a response pretty quickly, somewhere around 3 milliseconds. So just to verify that this is actually working, what I did was I actually just uploaded a ASPX shell to that VM as well, and I uploaded fscan, which is a command line port scanner that you can use, and I'm just going to run fscan against the exact same range of machines to verify that that scan is actually working. So I'm just going to go ahead and run fscan against dot 30 to dot 40. And this will go really quick, hopefully. And what's going to happen is it comes back with 31, 34, 36, and 38 are listening. So if I go back to the results of the scan here, it's pretty much those exact same machines that the little hack utility here determined were open. So that's just sort of an example of how this callback mechanism can really be abused to start issuing arbitrary requests to other machines, again, potentially on an internal network that you wouldn't normally be able to get to. And if anybody's interested, I can post the code to that utility. It's not very useful. It's just more of a funny thing. So the next walkthrough is going to be a secure WCF binding. And this was one that I had a demo lined up for, but I don't think we'll actually do a demo, but it certainly makes sense to go through it. The WCF framework allows developers to implement the WS security standards pretty easily. So WS security allows for things like message level encryption and all sorts of stuff that make it very cumbersome to start talking to the web service manually, because you really can't even craft, you can't really craft those requests manually because you have to negotiate certificates and all that stuff. So there's a handful of options that are going to be very important to figuring out how you're going to talk to a web service that uses one of the security settings. The most important thing is going to be it's driven off the mode, the security mode that it's operating in. So if you actually pull the metadata for a client, we'll actually look at this is the metadata for a secure web service I've got on port 89. This is the test utility that comes with Visual Studio. It'll actually go through using that metadata and create the configuration file that you would need on the client side to talk to this web service. So if I look at the security mode here, I can see that it's actually running in message security mode. That's always, the security mode's usually going to be either none, which is great, then you don't have to worry about this, message, which means it's going to do message level encryption, transport, which means it's going to require SSL or some other transport encryption, or message and transport, which means both. So the reason this is important here is that if you see message encryption, normally you're going to need, the requirement is you're typically going to need at least one certificate to use message level encryption. Now that doesn't mean that you're going to need to have a client-side certificate. It just means that you're going to need to use a certificate, potentially one that's going to be provided to you by the web service. So there is a scenario that you can set up where you can have anonymous message encryption. And the reason for that is the encryption is going to serve as just to protect the data. We're not interested in authenticating the user with using message level encryption. We just want to make sure that we don't need, in this case, we might not be using SSL, so we can exchange sensitive data and know that there's going to be a secure key exchange that occurs, and a middleman is not going to be able to read that data. So if you actually try to communicate with this service initially, you're going to get an error that gets thrown by the framework. And the reason for that is that you'll see down here, there's a certificate, an encoded base64 encoded certificate value. It's probably hard to see, and I can't increase the font size on this tool, unfortunately. But that's actually the server certificate. And what you can do here is that if you just take that certificate and plop it into, it's base64, so just plop it into a file and then import that locally, you'll then have the server certificate that within your certificate store that you can use to start talking to the service. The reason it's going to throw an exception is that this certificate, if this was a valid SSL certificate issued by a trusted CA, you can actually do this out of, you don't necessarily have to import the certificate. The problem is if you try to do this now, and I can even try to invoke one of these methods and see what happens, you're normally going to get an exception that gets thrown. And the reason for that is that the service, well, I think in this case I actually imported the certificate before the demo. But normally you're going to get an error, and the error is not actually very helpful. The error is just going to say the SOAP security negotiation failed. So if you see this message, that doesn't mean that you don't have the right certificate. That just means the certificate, there's probably something wrong with it. And we can take a look. Let me just run a Wireshark on that interface so we can actually see what the data that's going across the wire looks like. So if I go in and invoke one of these methods here, do 1 - 1. What we should see here is that when I decode this stream, it's actually all, the message payload is actually encrypted. What's actually happening behind the scenes here. There's one to initially negotiate the key exchange. There's about a series of 4 or 6 requests for just one service call. So this is a good example of where you're going to need to use one of these tools that support, and again, you're going to be very limited. It's going to basically be either WCF Storm or the Visual Studio Test Client. Probably a handful of other ones out there. If anybody knows of any good ones, certainly let me know, because I'm always looking for more tools that will allow you to fuzz the inputs pretty easily. So the other thing you may be able to do too is if this is a client application, if you're getting certificate errors, let's say you don't have the ability to import a certificate, sometimes that can be a little tricky. If you have a configuration file on the client, you can just turn certificate validation off. So if this is an application that you're testing, a thick client, and you're having issues with it, just go to the configuration, add a specific behavior to the config file, and that'll actually disable the certificate checks. And then the other option you have is with WCF, it also supports the classic WS Security username and password credentials. So if you don't have a certificate and it's not using anonymous message authentication, you're kind of out of luck. You're not going to brute force the certificate. But if it's using a username and password authentication, then you can easily brute force this. And this is one that most of the tools out there do support. So SOAP UI, for example, supports this. You just go to the WS Security username option, and it's basically just a plain text username and password that gets sent in a header. So you can easily try and guess this or brute force it. The one thing to point out here is that you cannot actually do this over HTTP. WCF will not allow a web service to use this authentication mechanism unless it's going over a secured transport. So again, that's kind of a good thing that Microsoft's done to sort of prevent anybody from inadvertently exposing one of these usernames and passwords in the clear of the wire. And then the last option you can do is if your tools aren't working or if they're using some ridiculous binding, because the bindings, again, there's 10 of them by default, 10 or so by default that you can use, but then there's a custom option that lets you mix and match any of those security settings. So every now and then you may run into a scenario where the tools don't actually support the binding that you're using. And if that's the case, it's very easy to write a custom test client using WCF. It's somewhere usually on average of about 10 lines of custom code. And the reason for that is you're going to leverage, as long as you've got metadata, you can leverage the service utility that comes with Visual Studio to generate an interface file, and then it's really very simple to convert that interface file into a console utility. This is basically what the custom code would look like. Once you have your interface, you just basically create a new instance of the client, and then you start calling methods on that client. So as a kind of a cheat sheet here, there's really 3 basic steps that you can do to do this very quickly in a matter of 5 minutes. The first is you use the service util to generate your client proxy. And then all you do is you can open up that client proxy, and if you just paste in this class below all of the interface code, you just add, you don't necessarily have to create a new file for every class. That's certainly the way that you would do it in a real code base, but if you're just trying to hack something together, just tag this code snippet at the bottom of the CS file that the service util generates, and then just add a reference to the system namespace at the very top. So put system using at the top. And what that's going to do is it's going to compile into an exe that you can then use to start directly calling methods on the web service. And the nice thing is it's automatically going to, let's say we're using message encryption here, for example, it's going to automatically negotiate that connection for you and do all the heavy lifting in the background. So you can really just start worrying about fuzzing those methods and not worry about all the other sort of noise that WCF would normally require you to handle. So the long and short of it is that the bindings are a bit of a headache when it comes to talking with the web service, because depending on what you need to do, you're going to have to search for some non-standard tools out there, or perhaps, like I just mentioned, create your own utility. The good news